In this video, we'll see the beauty of multi-threading in Unity and C#. Let's start by seeing what is multi-threading. Multi-threading in computer science means doing things in parallel. So I have a method that calculates something and it's a bit more complex. And imagine that it's too complex that it blocks my program for a few seconds until it finishes calculating. So I will use multi-threading. I will give this process to another thread for me to handle and to calculate, and my main thread just keeps running the program, and when it gets the result of this calculation, it can do anything that it wants with it, so it can show it to the user or something like that. We see this process a lot when we are using applications or games that are connected to the internet. An application that is connected to the internet must send a request to the server, and the server needs to process this request and for example search in the database or do some calculations, and then returns a response to the user. And this process will take a bit of time depending on the complexity of the method and the speed of the internet. During this request, the user's process must not be blocked. They should be able to continue their usage of the application. This is the magic of multi-threading. A process, as you can see in the image, always has a minimum of one thread. So the main thread is the one that is executing the code of your program. But this process or game or application can have multiple threads that can run in parallel. Now that you know what multi-threading is, you will see how we can use it in Unity. In Unity, there are three ways that you can use multi-threading. There is coroutines that you may already be using the IEnumerators and start coroutine and methods like that. There is C# multi-threading, the multi-threading that is integrated inside the C# language. And there's Unity's job system, which is a new system that Unity has introduced recently, and it uses entity component-based structure to do things in parallel. We'll take a look at the code for the first two, but the third one is a bit more complex, but I will provide links for you so that you can take a look at it if you're interested. We'll start off by coroutines. So a coroutine itself is not really a method that is doing multi-threading, but you can use it to do synchronous methods such as loading the scene in the background. To take a look at the example code that is provided in Unity's documentation, as you can see here, in the update method, we have a code that loads a scene in the background when we press the space key. So when I press the space key, the method load your async scene will be executed using the start coroutine method. So if you have a coroutine, you have to call it using the start coroutine method. And the return type of your coroutine must be IEnumerator. The code that is written here uses the scene manager.load scene async to load the scene to the memory, but without interrupting the user's experience. So here you can, as you can see, there is a comment here that says you can actually create your loading screen here. So to handle this synchronous operation, you have to call this async operation. You have to create an object of this type, and you have to call scene manager.load scene async, and this is the name of the scene that you want to load in the memory. And then to actually wait for this loading to finish, you will call while async load is done, while async load is not done. You'll just yield return null. So what this method do and what this yield return does is after each frame it will check if this operation is done, and if it's done, well, it will load the scene automatically. But if it's not done, it will just yield return null. This is to avoid this coroutine blocking your process. And in a coroutine, you must always have a return something. So in here we just return null because the scene is not yet loaded. Keep in mind that this is not exactly multi-threading, but it's actually doing an operation in the background and just checking each frame if it's done or not. So we could say that it's semi-multi-threading. The second way to do multi-threading is using the C-sharp's multi-threading functions. The C-sharp's multi-threading system is inside system.threading namespace, so make sure if you want to use it, you have to import system.threading. And to do this functions in the background, you have to create a thread start. So as you can see, the main method of my application here in this code in the tutorials point is here. I create a child reference of type thread start, and inside this new thread start I will pass the call to child thread. The call to child thread is another method that is created inside this class. And keep in mind that here my main method is static, and so that to call a new thread, to call a method in a new thread, I have to call that, I have to create that method of type static. And then to actually call this child method, child thread, you have to create a thread, child thread, new thread of type child reference, so of type thread start, and then you'll call the start method on the child thread. Two things that you have to keep in mind here is that the child threads are actually threads that are created by the main thread. So that's why we call them child thread, because the parent of these childs is actually the main thread. So if you have multiple threads, there is, well, surely it's the main thread that created at least one of them. And then these child threads themselves can create child threads of their own, but that's going to make things complex. You have to keep in mind that while you're using threads, there are risks and there are problems that exist in computer science. For example, there are critical sections, there are global variables that multiple threads must not access at the same time. So imagine you have an integer of score, a players to score, and you are changing this score inside the main thread, but a child thread is actually going to access this variable as well. And this is going to create a problem, because modifying a global variable in two different threads is not a good idea, because it's going to modify the variable in ways that you don't want to do that. However, most of these problems are handled in Unity's or C-sharp's multi-threading systems using the thread safe and things like that. But if you're doing things in a higher level, keep in mind that using multi-threading is not always a good idea. The last one is Unity's job system. This system is Unity's modern multi-threading, and it will increase the performance of your games massively, but using it is a bit more complex. You can check out Unity's documentation about C# and Unity's job system. You can see in the documentation that you can use the C# job system with the Unity Entity Component System, or ECS, which is an architecture that makes it simple to create efficient machine code for all platforms. So make sure to check it out if you're interested.